Hello and welcome. In this video, we're going to discuss voltage sources in series. Voltage sources in series are going to sum together, right? And the direction matters on those. So let's identify the direction of all three of these batteries, and we can determine what XMM2 would read around our final resistor here. So we see that we have a 14-volt source. The long leg of that battery source is up here, the positive side, and the negative side's on the bottom, which means that the current's going to flow up through this voltage source here. The 20-volt source that we have has the positive at the top, negative at the bottom, and we see that that's going to flow current up through that one as well. And this 4-volt up here has negative on this side and positive on the other side. That's going to flow it across this way, which when we look at all three of those, we see that all of them are flowing in the same direction. That means that we're going to have a flow of current that's going to sum together and allow us to have all of it drop across this one resistor. So to find the voltage potential across our resistor, we sum those up. We can say 14 plus 20 plus 4 is going to give us a full magnitude of voltage of 38 volts. So that's what we expect XMM2 to read, 38 volts. And if we wanted to determine the total current that this voltage provided, we can use this voltage here back into Ohm's law, right? Voltage, current, and resistance. Current is equal to voltage over resistance. And now we would place our 38 volts on top and divide it by our 1000 ohm resistor, and that would give us our total current in that circuit. So the second circuit here has a different orientation on one of its voltages. The positive and the negative leads us to have 14 volts, the exact same one as before. The negative is on the top of this one, right? So our 20-volt source is actually going down instead of up like it was before. And our 4-volt has not moved, so the negative on top, the positive on this other side here, and we see that flowing towards our resistor there, which means that we have the 4-volt coming down along with the 14-volt, and we have this 20-volt leading the opposite direction coming up through this side here. So they're going to oppose each other, which means that we need to figure out the difference between these two voltages. So we'll say that we have 14 volts minus 20 volts plus 4 volts, right? And that gives us negative 2. Right, negative 2 volts. So we expect negative 2 to be on this XMM3, and that's going to determine the current. So the current for this circuit, I, is equal to negative 2 over 1000. Right? So that's going to be a much smaller current through there, and it's actually going in the opposite direction, right? Because this negative is not telling us that our current is negative, because current is a factor over time. It's telling us that our potential is in the opposite direction that we expected it to be, right? Which means that we had an anticipation that the current would flow down the same way it did before, but it's actually flowing up. It's actually having more magnitude flowing the opposite direction. Right? But it's still going to be a pretty low current because we only have 2 volts of potential due to the backwards battery canceling out the other 2 potentials that we have there. Right? Let us know if you have any questions.